in this video I'm going to do a quick recap of the compound angle topic. I've picked one question from kind of each exercise from your textbook and maybe a couple of past paper questions just to let you refresh your memories on doing these. So question 1 asks you to expand and simplify sine bracket x minus 60. So the minute you see that, you should recognise that it's going to use the expansion of the formula that's on your sheet, which I've put in the corner here. So the sine expansion is the one where the signs stay the same. So if there's a minus in the bracket, it still becomes a minus at the side. So we're going to write this out as sine x cos 60 minus cos x sine 60. From there, we can't do anything with the sine x, but we do know what cos 60 is using our exact values. So if you can't remember your exact values off by heart, remember your 60 comes from an equilateral triangle that was all sides of 2. But when you split it up, the base is 1 and this is root 3. So this angle here is 60. So cos of 60 would be your adjacent over hypotenuse, which is a half. So you've got 1/2 sine x there. Take away sine of 60 would be your opposite over hypotenuse, so it would be root 3 over 2. So we take away root 3 over 2 cos x. And you can't do anything else with it from there, that's just your expansion and your simplification. Okay, in this one we're going to expand with cos. Cos expansion is easier to remember because it's just cos, cos, sine, sine. But notice your signs are changing. So where it was a plus becomes a minus and vice versa. So our plus will have a minus between it, so it'll be cos x cos pi over 4. You might want to change that to 45. The plus becomes a takeaway, and then it will be sine x sine pi over 4. Now, pi over 4 is really just 45 degrees, so that comes from your isosceles triangles of sides 1, 1, makes the third side root 2, and your angle 45 in there. So sine and cos of 45 are the same, they're 1 over root 2. So the cos of pi over 4 becomes 1 over root 2 cos x minus, again, 1 over root 2 sine x. And that's that one done. Question 3, we're told what sine of A and sine of B are, and we have to show that the expansion of sine A plus B is 4/5. And the minute you see this, I want you to draw some little triangles for me. So I'm going to draw 2 right angle triangles, one with an A and one with a B. So if sine A is 3 over 5, that means your opposite is 3, your hypotenuse is 5, and that was your classic 3, 4, 5 triangle. For sine B, your opposite would be 7, and that would be 25. You can then use a bit of Pythagoras to work out the third side, which gives you 24. Okay, so now I've done that, I'm going to go do my expansion for sine A plus B. So that would be sine A cos B plus cos A sine B. So the sine one I always remember is just a wee bit symmetrical and it goes A, B, and the coses are in the middle. Right, so sine of A would be your opposite over hypotenuse, which is 3/5. Cos of B would be your adjacent over hypotenuse, which is 24 over 25. Plus cos A would be adjacent over hypotenuse, which is 4/5. Times sine B is opposite of hypotenuse, so 7 over 25. So this really tests your SOHCAHTOA knowledge. Right, from there we're going to do top times top, bottom times bottom. So 7 times 24 is 72 over 125. 4 times 7 is 28 over 125. Then when you add them together, that gives you 100 over 125. Both of them divide by 25, so that gives you 4 over 5, which was part of our proof, so that was as required. So the minute you see this sine A and sine B, you want to draw some triangles, and then that'll allow you to get cos A, cos B, tan A, tan B if they ask for any of them. Okay, so it all comes back to your wee triangles. Similarly, here's another one. It tells us cos A is 12 over 13. We have to find an expression for sine 2A and cos 2A. So this is going to use the other part of your double angle formulas, these ones here that are on the formula sheet that I've got in a yellow rectangle. So I'm going to draw my triangle first of all. So cos A is 12 over 13. So if that's angle A, this is your opposite. Your adjacent is 12 and your hypotenuse is 13. Now using Pythagoras, that means that the other side of your triangle is 5 because it's 169 minus 144, which is 25, and the square root of 25 is 5. Right, so from there, they want to know what sine 2a is. So, sine 2a, using the expansion up here, I'm just going to write this out again. So, sine 2a, we then write as 2 sine a cos a. And then we substitute in the correct fractions. So, sine a would be opposite over hypotenuse, which is 5/13. And cos a was 12 over 13. We were given that one already. Right, from there, multiply straight across. That gives you 2 times 5 is 10, times 12 is 120. All over 13 times 13 is 169. And there's absolutely nothing that cancels there, so there's your answer. For cos of 2a, you have options, okay? You can choose any of these three here. I would recommend you probably avoid the third one, right? Because it's got a negative in it. It's your choice whether you want to use the top one, which is cos squared minus sine squared, or the second one. What I'll do is I'll do both just to show you that they both work. So I'll take the top one first of all. So I'm just going to make a wee bit more space over here. Oh no, I need my triangle. What am I doing? Right, I'm going to change my pen colour so it doesn't all kind of bleed in together. Right, so I'm going to do that is cos squared a minus sine squared a. So cos squared a would be 12 over 13 squared. Take away sine a was opposite, so 5 over 13. So that was 5 over 13 squared. Then you just square the top, square the bottom. So you've got 144 over 169 minus 25 over 169. And if you do that, 144 take away 25 is 119 over 169. Okay. Now I'm just going to prove that it works doing the other one if I do it with the 2 cos squared a minus 1. So cos 2a equals 2 cos squared a minus 1. So that meant 2 times, now cos a was, let me just remember, cos a was my 12 over 13. So that's 12 over 13 squared minus 1. So that was 2 times 144 over 169, take away 1, which is 288 over 169. And I'm just going to change that 1 into 169 over 169. And then when we work that out, 288 take away 169 is 119 over 169. So that was just to show you that both give you the right answer. I know which one I preferred. I preferred the one I did in green. I preferred the cos squared minus sine squared because there technically a wee bit less working to do in that one. Okay, so the next style of questions you come across are solving some trig equations using your substitutions. So sine 2x you replace with that expansion. So this becomes 2 sine a, well it's x, sorry, so I was going to say a there. So it becomes 2 sine x cos x plus sine x equals 0. So I really shouldn't have that equals sign there. Right, from there, it's some form of factorising. Could be common factor, could be difference of two squares, could be a trinomial. In this case, you'll notice both things have got a sine x. So I take out a common factor of sine x, and that leaves me with 2 cos x plus 1 equals 0. From there, you split it into two little equations, both equal to 0. So sine x is 0, and 2 cos x plus 1 equals 0. Now I'm just going to rearrange this one, so that would be cos x equals, and it would be negative 1 all over 2. Now, from this, you then have to use your sine and cos graphs. So your sine graph is that one, and sine of 0 is sine x wants you to know all the places here on the graph where it equals 0. So the roots of it. So there's 3 possible answers here. So x can be 0, it can be right in the middle at 180, and it can be at the end at 360. So there's 3 answers there. For the second one, they want you to solve cos x equals -1/2. So technically what you're going to do is work out shift cos of a half, and the negative just helps you decide that you're not using all and cos, you're actually going to use sine and tan. So shift cos of a half, you don't have a calculator, but it is an exact value. So shift cos of a half is 60. Okay, so I always remember that sine 30 is a half, and that makes cos of 60 a half. The 30s and the 60s alternate. So the acute angle is 60. So then what we do is we do 180 take away 60, and we do 180 plus 60. So 180 take away 60 is 120, 180 plus it is 240. Now what I like to do at the end is I just like to do a nice conclusion with all the answers in order. So we had 0, 120, 180, 240 and 360 all as possible answers there. And they should all probably have wee degree signs. Okay, so that's that one. Let's look at another one. Okay, this time we've got cos 2x to substitute in. Now, what you substitute in depends on what else is in the question, because you'll notice your cos formula has a cos and a sine. It has one with a cos in it and it has one with a sine in it. If my equation had another sine x somewhere in it, I would probably use the bottom one, but mine actually has another cos in it, so I'm going to use this one here. The other two are no use to me. So we're going to replace cos 2x with 2 cos squared x minus 1 plus cos x. Now that there is now a trinomial, so I'm just going to put it in the correct layout. So we're going to go into 2 brackets, one with a 2 cos x and one with a cos x. If you're struggling and you don't like doing that, you could always just treat this as 2c squared plus c plus 1 at the side and then go put the words back in, equal to 0. Right, numbers that multiply to 1, it's obviously just 1 and 1. You need to make this add to positive cos x, so that means the plus goes here and the negative goes here. Because when I expand this out, that'll give me a 2 cos x, that'll give me a minus 1 cos x, which makes positive 1 cos x, okay? So a wee check. Now that you might not do factorising that way, but that's just a quick way I'm doing it. Okay, from there, you then split each equation equal to 0. So you have 2 cos x minus 1 equals 0, and you have cos x plus 1 equals 0. From there, that gives you cos x equals, oh, there's that 1/2 again, and that gives you cos x equals minus 1. Right, so from your cos graph, I know that cos of 60 is a half. Cos is positive, so I'm using all and cos. I'm not using sine and tan at all. So my acute angle would be, now it's in radians this time. So I'm just going to keep it all in degrees and then turn it. So that would be 60. So x would be 60 or 360 take away 60, which is 300. Now to turn that into radians, 60 goes into pi 3 times. Just shift this up a wee bit. So that would be pi over 3. And 60 times 5 is 300, so that would just be 5 pi over 3. Right, let's go solve the other equation now. Cos x equals -1 is here, right in the middle. So that is just at pi for 180. So my final conclusion, x equals pi over 3, pi, and 5 pi over 3. Now I know my examples don't cover it, but I just want to discuss the occasion where you maybe had an equation that ended up like this, that cos x equaled 3. You can't do shift cos of 3 because your cos graph only goes as high as 1 and -1. So if you ever get a number here that's bigger than 1 or less than -1, you can't solve that one, so you simply write under it that there are no solutions. You don't need to say why, you just say no solutions. And the reason is because shift costs of 3 on a calculator would tell you it's an error. But remember, this is all pretty much on calculator. Okay, so I pulled this question out from 2017 and it was worth 3 marks. When it was 2018, worth 3 marks. So let's have a look at it. So it's all to do with substituting in those formulas from before. So the first thing out, that sine 2x has got to go. So sine 2x will get replaced with 2 sine x cos x. All over 2 cos x. And then from there, before I do the next bit, you'll notice the 2's will cancel out and the cos will cancel out. And that'll just leave you with sine x for the first term. Okay. Now let's look at this next bit. So I've got minus sine x. Then I've got cos squared. Now, this isn't part of higher. This is part of National 5. At National 5, we teach you that sine squared plus cos squared equals 1. And from that, you can rearrange it and say, well, that means that cos squared is 1 minus sine squared. So I'm actually going to replace this bit here, cos squared, with 1 minus sine squared. Right, from there, so I've got sine x on the left, multiplying out this bracket, sine x times 1 is just minus sine x. The double negative will turn into a plus, and then sine times sine squared will give you sine cubed. These two things here basically cancel out because you've got 1 sine minus 1 sine, so that's gone. And then you're left with just sine cubed as required. So we've done the proof. Okay. They're not the nicest, are they? Let's try another one. So this next part of the question, part B, you already done part A previously, okay? So they want us now to differentiate this worth 3 marks. So basically, if they want you to differentiate this, and we already said that was sine cubed, they want you to differentiate sine cubed. Now, I always think it helps to think of sine cubed as this, okay? And then we're going to do the chain rule. So if we differentiate, now I need to do my handy hint at the side. So I do sine cos minus sine minus cos. So if we are differentiating, we work our way down the list. So we times by the power, which gives us 3. We lower the power. And we times by what we get when we differentiate the bracket. When you differentiate sine, it moves down to cos. So that gives you cos x. And a nicer way of just writing this now is 3 sine squared x cos x. So there you go. That was just a wee past paper question I thought I'd throw in as well. Thanks very much for watching.